Last talk of the FOSDEM 2017 Distributions Demo. Thank you very much. And I would like to introduce Peter Robinson talking to us about using Fedora for IoT.
Hello everyone. I'm sorry for stopping you from your beer. So I'm going to talk about architecting a secure IoT platform using a generic distribution such as Fedora. So the Internet of Things has the potential to change the world, not necessarily in a good way. Linux distributions have been around for some time and have a lot of the dealing with security and CVEs and updates and distribution mechanisms and all that sort of fun stuff long solved and relatively straightforward. And so why can't we use the current knowledge to continue to evolve and improve the IoT to make it a little bit friendlier place for the world as a whole. This is a general overview of an IoT stack. One of these days I'll actually get around to doing this graphic myself because, as someone pointed out, it has a Cortex-M series which you can't exactly run Fedora on. So what would you use as a base platform for IoT if you were to use it for Fedora? Well, the first technology there is a tech called Atomic or OS Tree. It enables a single snapshot upgrade, snapshot rollback of a distribution in an atomic state. So if you boot a device with an update and it doesn't boot or it doesn't have network connectivity, you can run a series of health checks and reset back to the old version. So you should never get into a situation where you have a brick device or an uncontactable device or a device that doesn't have access to all its sensors. You'd obviously need a very good focus on security and multiple architectures. Obviously x86 is a fairly widespread with a bunch of IoT, but obviously ARM, and more so these days ARM64 is certainly a series of well-known architectures that are deep into the IoT space. And that's basically my role, is to build a IoT platform using Fedora as a base as part of my job at Red Hat to help define. We're going to initially focus on a gateway platform, both industrial and home and various other use cases, and focus on a handful of devices, although it will work on pretty much any device that is supported by Fedora. But yeah, so we, like in the ARM space, we probably support 200-300 different ARM devices these days, but it's a lot of work to be able to polish each and every one of them. So we'll focus on the Raspberry Pi 2 and 3 because obviously they're very popular. The solid run Hummingbird Edge devices, which are the first version of the Linaro Lite reference platform. The BeagleBone variants, because they're quite good for IoT. Intel dual platform from an x86 point of view and a Pine 64 from a ARC64 point of view. But it's sort of still a bit up in the air and we'll evolve it as things happen. Yeah, so this is basically an overview of what the gateway will be, based on a minimal atomic base image with containers to add functionality. And in the F26 cycle, we'll focus on some example containers like an MQTT container, and also various different networking technologies, both wireless and wired, such as 802.15.4, Bluetooth LE, and various other open standards. Obviously, security is a very important and poignant point when it comes to IoT, and there'll be a focus on things like UEFI or OPT as part of a secure boot and verification. So from the moment the processor boots, whether it's using TPMs on x86 or ARM trusted firmware and various other technologies like that from the ARM platforms, to give us the ability to verify the entire OS through the boot process to make sure it hasn't been compromised. Dependency minimization. There's generally no real need to ship 3 or 4 TLS stacks, for example. If you can ship less, you've got less sort of coverage and less chance of major CVEs and compromise. And things like seccomp and SE Linux, toolchain related functionality, sandboxing, various systemd functionalities, and the kernel self-protection project. There's a bunch of different sort of initiatives there that are helping secure and reduce, so and even eliminate entire types of sort of compromise. And then obviously with containers, you can namespace them and isolate them, which means each sort of individual secure service that's running is in an isolated context with either access control or proxy or what have you to be able to access different parts of the network or different components. Different network isolation technologies, device isolation and policy routing on the gateway level to ensure that if you've got an entire class of device that you don't want to connect to the internet, that you can identify, whether it be via MAC address or OS fingerprinting and things like that, you can set up policy routes to either null route them or isolate them to ensure that, you know, if you're acting as the gateway, that these devices can't become part of a botnet or other such. Network support, focus on open standards, so things like 802.15.4 rather than proprietary technologies such as Zigbee and other sort of lock-in technologies where you've got a license or patent or what have you. 6LoWPAN as a IP protocol, and various other, and things like older technology such as RS485. Someone was asking me about Modbus the other day. CAN support for controller area networks, etc. So this is a sort of general, typical wireless IoT topology as a sort of just a general overview. And so this will be the sort of initial focus point from my point of view with Fedora IoT. Some sample containers, OpenThread and other networking services, MQTT and various other messaging stacks, caching modules and various middleware, and then a selection of possible IoT specific stacks. There's been a couple of people that have been slowly packaging up Node-RED, and each time a new release comes out they add a few hundred extra dependencies. I'm fairly certain they now depend on over 50% of the Node.js sort of repository stack, which is, I believe, one of the largest repositories in terms of pure numbers of libraries on the internet. So it's a very interesting project, but it's vast in terms of, I think they've already packaged up something like 500 different Node.js dependencies, and there's still only a smaller way there. So we may look and see if we can just pull that in and run it container style in the short term while we get all of that done. Plus, there's some interesting IoT projects coming out of the Apache project, such as Kura and Hono, and similarly related projects. Soletta is an Intel IoT project, which is already packaged up in Fedora, and there's a number of other ones that people have shown interest in. So are we just doing a gateway? Initially, yes, but it's just a starting point as a means of doing a proof of concept and driving focus. I have a tendency that if I'm not focused on something in particular, I have lots and lots of ideas, and I'll deliver little bits of lots and lots of ideas, and we won't end up with something that's particularly useful. It gives us a good starting base to build both the different options, but also the community around. And it'll be a combination of industrial IoT and home, because there's a lot of people interested in the home side of things, but obviously Red Hat from a commercial point of view is more focused on industrial and medical and other such sort of industry gateways. And it'll be initially a proof of concept as a testing platform. Nothing set in stone. It will evolve and change as necessary and as, you know, people discover things. What other options? Imaging stacks. I've had a bunch of interest around different sort of embedded devices with cameras used for whether it be security and detection of like movement or other sort of OCR style recognition or image recognition and various other stacks like that. And there's some other interesting projects where we're having some discussions with, there's an AI platform called Mycroft, which is open source, and they're very interested in working with us to do some IoT related stuff, and too numerous many ideas to mention. Like I come up with a different idea every other day. So yes, in summary, I feel Atomic is the right way to go in terms of updatable, secure devices, multiple architecture support from the outset, initial reference devices with focus, and a base platform and gateway functionality to start with. Any questions?
So you talked about dependency reduction, so you wouldn't have, as you say, too many libraries. So that involves not using the standard Fedora builds, but you're reading
no, we would
in a slightly different way to get a minimised kind of pile. Is that the idea?
So to repeat the question for those that might be watching online, does the dependency minimization result in different Fedora packages or forks of the package? No, it doesn't. We'll be working with the maintainers of those packages to ensure that that's the case. And there's already other initiatives as part of...
Build your Atomic thing out of standard Fedora.
Yep. Yeah, the intention is to be 100% within Fedora. We're still in the Fedora 26 timeframe. It'll probably be part of the Fedora Playground branding, but the intention is to have it eventually as a fully accepted, similar to workstation and server and cloud and Atomic, the different projects there. The intention or hope from the discussions that I've had with the FPL is basically to sort of have it a fully core part of Fedora, or at least potentially.
You mentioned that you have a specific set of reference devices. Do you also have a specific set of transmitter or stuff like that? Because all the reference devices normally don't have any support for CAN or 15.4 or something like that out of the box, so that might be you need extra hardware for that. So you have a specific set of devices as well, or?
So the question is around the reference device support and specific hardware support within those devices.
For the different protocols they want to need wireless or wired or whatever.
So by default, I think all of those most of those reference devices either have wireless and Bluetooth or options of. So like the Raspberry Pi 3 has both wireless and Bluetooth. The Hummingbird has options of wireless and Bluetooth. The BeagleBone now has a couple of different models that come with both wireless and Bluetooth. The vast majority of them already have CAN support, actual onboard CAN controllers, except for maybe the Intel Dual. But at least so the IMX6 has CAN, the Raspberry Pi doesn't have CAN. So it'll depend a little bit on the device. And depend a little bit on the matrix of what we decide to support initially. And we'll adjust devices and support matrix as we go.
Yeah, but just wondering, because for 15.4, for example, I only know one board that is supporting it out of the box, or the other ones have like added receivers with that. And so Bluetooth is more or less the same, because we might have a Bluetooth module speaking low energy or something, but it might not be 4.2 or maybe even 5 at some point or so.
Yep.
You might need that for mesh networking and so on. So you might need to have some extra hardware.
Yeah, correct. Yeah, so in the case of like 802.15.4, there's 2 or 3 devices that come with it on board, but some of the different controllers are better or worse supported upstream. And there's a couple of USB ones that are very well supported, which are what. Initially it'll probably be like, I personally have interest in the 802.15.4 stuff, and I have a bunch of different devices at home with it on board, but we will probably say that, like, initially, until there's more hardware shipping, that will, recommend the USB.
You're gonna work with what in the security stuff. One thing that what was missing was any communications over the internet. There was no mention of like SSL certificates, and like Let's Encrypt or something would provide a way to ensure that you have trusted certificates.
So the question is around securing SSL or TLS-based services outbound to the internet. It's not explicitly mentioned on the slide deck, but it's essentially service by service. So in the case of MQTT, it supports that out of the box depending on which broker you're using. The underlying base platform, other than pulling down like the updates, won't have any outbound services to note, and then each one will depend on the container that it's running on. Does that answer your question, Dennis?
Not really.
On your picture, there was like a remarkable number of devices connected, and that raises the question: what's about the management approach to that, monitoring approach to that? Is there something specific which Atomic cost doing something like that?
So the question is about the management of vast amounts of devices. At the moment, Atomic doesn't have a general story there, but it is also being worked on as part of that team. So the intention is there to consume their standard mechanisms of dealing with it as it's developed. It's certainly something that's on my roadmap. Management of devices, managers of devices connected to the gateway, control of those devices, centralized policies, centralized updates, and yeah, it's probably something that I should put on the slide deck, but it's certainly something that's like in the future. Yep.
If you look at the history of OpenWRT, or REDE as it's called nowadays, is there anything like lessons learned from your position? Are you interested in taking another approach in some way? Is there any conceptual difference?
So the question is, looking at projects like LEDI, OpenWRT, whether there's intention to do lessons learned from those sort of projects.
What are the problems you have identified there, and are you taking another approach to tackle them?
Possibly. Some of this is still research. Some of this is the way we're doing it in Fedora. There's certainly different approaches that we can look at. There are, projects like OpenWRT have been sometimes effective at dealing with things like security updates, and sometimes not so effective due to political and social issues within the project. Like they're quite often a long way between releases. So there's absolutely things to learn, and there's absolutely ways we can change things to make it better. And the intention sort of there is to get something working and then evolve as we go.
So I'm not particularly familiar with your atomic thing, so maybe this is a long question to answer, but you said you had atomic rollbacks.
Mm-hmm.
Is that actually implemented, given that you're working from standard packages? What's doing there must be something outside the image to do the new image upload?
That's part of the atomic functionality. And
where does it live?
I think you need to explain OS tree and atomic with it, rather than assuming people know what they are.
true, but I don't think we've got enough time to do that.
Yeah, okay, fair enough. Double layer.
OS tree is a system that you can feed in RPMs or just binaries, and it makes a snapshot. It stores things in a Git-like manner, and so it enables you have different refs, and you can just boot the previous ref. Like, as part of the command line options, you set the root file system that points at the ref, and so the atomic rollback is that you still have the previous version installed, and you just boot into that, as opposed to...
Yeah, so it's like the update is like a delta between the two, and you just...
OS tree is the essential technology.
Yes.
That tech.
Yeah, and I mean that's not RPM specific. There are projects that are using it. So like Endless Mobile is using it on a Debian-based distribution for their OS as well.
Could you use OpenShift to manage all that stuff?
The question is, could you use OpenShift to manage some of that stuff? Potentially. I mean, OpenShift is based on Kubernetes, and Kubernetes is sort of like cluster technology. So you could probably use applications running on an OpenShift platform as a management thing, but OpenShift itself, I'm not sure would be, at least out of the box as it stands now, necessarily useful. But certainly, like for IoT backend platforms, OpenShift is like the perfect candidate for running those side of things, but not so much on the actual device. Any more questions? Excellent. I'll let you all go and get beer.